there's one more important non-log integrand that ends up on a log function. You should have met it before, but you probably haven't done too many questions on it. Does anyone remember what it is? Something where if I integrate it over here, it's not a log, but it's going to equal a log something over here. And it's not like either of these, okay? All right, let me ask you this. What's the integral of cos?
Negative.
The integral of cos.
Sine.
It's too early in the morning. My brain doesn't work with positives and negatives. I differentiate something, it'll give me cos. The answer is sine, just normal sine, okay? Plus your constant, okay? All right, if you integrate sine, all right, here we go. Now you know what's going to make up. Yeah, all right, good. So minus cos. Okay, so then when you integrate tan,
Secant squared.
let's try it out. So someone said, I heard a few people say sec squared. Let's just give it a go. Why not? You know, what is this? This is actually 1 over cos squared, isn't it? Okay, right? You see people shaking heads. Okay, well, the great thing about integration is you can always find out whether you're right just by differentiating it, right? So let's give it a shot. Differentiate 1 over cos squared. What do you get? I suppose I could write that as cos x to the power of minus 2, right? Let's see here. So, sorry, the derivative of, right? So, chain rule. Differentiate the inside, you'll get a minus sine x. Differentiate the outside, that's a minus 2, that'll come out the front. Then the power reduces by 1. This has a double negative, so I'm just going to get a 2 sine x on cos cubed. This isn't looking promising, people. Okay, what did we do wrong? We didn't integrate at all. This is the derivative of tan. The derivative of tan is sec squared, okay? So this is not a good rabbit trail to go down, all right? Let's try and write this in a form that'll make it a little easier for us, though to be honest, I've been giving you clues all day, okay? Tan is a shortcut, isn't it? It's sine on cos. Now, just like here, well, we started with this, didn't we? Okay. Here, I don't quite have f dash on f, do I? I'm pretty close, but I'm not there. So we multiply by a constant to get there, didn't we? Now here, I don't have f dash on f, because sine is not the derivative of cos. What is the derivative of cos? It's negative sine, isn't it? Which is what we recognized here. Okay. So in order to get a minus sign up the top, you can't just put minus signs anywhere you like. You've got to put one out the front. That's what we did with the constant over there. It's still just another constant. All over cos. Oops. Why am I plussing C? Sorry, guys. Okay. Are we in a form we can use now? That's f dash on f. There's a minus sign just sort of hanging around like an awkward third wheeler on the front. Then we're in the form that we need. This is log of f, which is, in this case, cos. Plus my constant. Right? So this is probably the last important non-log integrand that ends up on a log function. Okay? These three you really have to wrap your head around. I'll admit this one doesn't come up all that often, but they'll expect you to know it and they'll expect you to get it right because it's on the table of standard integrals. Okay? So if you see it, don't panic. Go back and you'll see the result that it leads to, so it's not that hard. Okay? To be honest, where it starts getting confusing is when you start looking at inverse trig, and the integrals for that look very, very similar, but that's kind of why you get given a table standard. Any questions on that? Yeah, sorry.
For the log, like when you integrate and get a log value,
yep.
you put absolute value.
Ah, good. Right. So some of you will have seen. Let's start with just a simple one, shall we? I'm too excited when I'm looking. Let's start with this. So some of you may have seen, reading your textbook, tutoring, whatever, okay, that the integral of 1 over x is not log x. Some of you will have seen this. The integral of 1 over x with respect to x is log of absolute value of x. Okay, now let's just pause for a second and think about why. And the important thing is the pausing, to be honest, because a lot of people will just write this down blindly, and they're like, well, why is that true? The textbook said it. The textbook has to be true, which sort of amounts to, I read it on Wikipedia, so therefore, doesn't really say much about our mathematical understanding. Absolute values are tricky. You have to be careful with them. Why might you stick in an absolute value here where there's no kind of thing over here suggesting that you might need absolute values? Why might we do it? Okay, right, so the log function, there is actually something that gives us a clue. The log function doesn't have the same domain as 1 over x, right? What's the domain of 1 over x? What does it look like? It's this guy, isn't it? Okay, what's its domain on this? All real values of x except for 0. That's where your asymptote is. Okay? Whereas log x just looks like this. Okay? So its domain is positive x. Yeah? So why might we stick this thing in? Okay? It has to do with a specific kind of question, right? Because this is still a true statement. This is still true. Okay? Without the absolute values, it's still true. The reason you'd bring negative values in is if you're trying to work out something like, oh, I don't know, an area. Okay? Now, if you're calculating that area, right, see, you have to be careful. Let me ask this in 2 ways. If you're calculating the area, should you get a positive or a negative? If you're calculating the area, it must be positive because area, just like length, is a it only takes a positive value. Okay? But if you're evaluating the integral over there, all you're doing is evaluating the integral. Say from -2 to -1. What should you get, positive or negative? The answer is you should get a negative because it's beneath the axis. Okay? So therefore, look at this guy. Think about it. Okay? Suppose I wanted to, I need more space. Suppose I wanted to integrate 1 over x. What boundaries did I just give you? -2, -1. Okay. Now what would happen if I just blindly chucked in log of absolute value x from -2 to -1? What will happen? Is it going to work out? Because I'm expecting a negative, aren't I? Let's give it a go, shall we? Upper and lower bounds. Careful. Which one's the upper bound? It's -1, because it's bigger, isn't it? I know that the number looks, the value looks bigger, but this one is higher, right? So I say log of absolute value of -1. Now what? Minus log of absolute value of -2. Okay, what's the log of absolute value of -1? That's the log of 1 minus the log of 2. Sorry, that's not helpful, is it? That's an L. Okay. What's the log of 1? It's just 0, isn't it? Minus, this is 0.693, blah, 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 or something, right? Whatever that is. So therefore, what have we got? Okay, so this is good. We got the negative that we expected, okay? But now if I'm interpreting this in terms of area, I have to say, therefore, the area is log 2 units squared, okay? And you've got to say that. Now I know people are like, oh man, maths is doing that physics thing. It's just like, I have to write sentences. This is rubbish. This is why I did maths, so I didn't have to write sentences. You have to do that. I'll tell you why. What's the alternative to writing the sentence? I'll tell you what the alternative is, because I've seen it written down so many times. Okay? People say, oh, it's minus log 2, but I have an area. So they say, that's log 2 units squared. And a part of my soul dies every time, okay? You cannot just turn a negative into a positive because you wanted to, okay? So, please don't do that because it's not true, right? Write a sentence. You've formed an appropriate integral. That's the important thing, okay? If you wanted to avoid the sentence, if you so desperately wanted to do that, I suppose, should we do this? You see, I'm thinking about whether what you can do is form a different integral here. Okay, and you can reason that it's an equivalent integral. But see, then the problem is you have to reason. So you got to write a sentence anyway. Tough. So, moral of the story is, get to here. That's the correct answer. That's what the definite integral is equal to. If you ask to work out an area, write something to say it. Okay. Now, by the way, that was just talking about this one. Okay. You can see that it sort of extends as you go through. Be careful. 1 over x minus 1. It no longer shares the same domain as 1 over x. How is this domain different? 1 over x minus 1. It's moved over. Where's it moved?
Right.
1 unit to the right. Okay? And you can draw it and you can see the asymptote's going to be different. So therefore, this is going to be log of absolute value of x minus 1, but the domain is different for the values that change over. So you have to be careful. But that's what you use this for. Alright? Don't just blindly put in absolute values whenever you feel like it. Okay? If I saw this question, I would write that. Nothing to do with area. Okay? We bring in the absolute value because it actually has an effect on the definite integral. Does that make sense? Okay. Sorry, wait. Only half of you nodded just now. Let me try and say it one more time. The reason why the absolute value is important, why it becomes significant, is when you want to put in negative values. That's where it starts to break down if you don't have the absolute value. Okay? Because if I didn't have the absolute value here, you'd be, your calculator would kaput. Okay? So if there aren't, that's why you see, if there's no bounds, you shouldn't have to bring in an absolute value because you're never going to have to put in negative numbers. Okay? So you bring in the absolute value because negative numbers might be an issue, namely when you have a definite integral. Okay? Hopefully that makes sense.